Alright, so here's a quick one on the retrieval, which is going to help you with the ready and the go. Going to keep it simple. It says factor out the greatest common monomial. Monomial means one term, right? Binomial means two terms. So if you're going to factor out the greatest common one, think numbers then letters. What is the greatest common numerically between 3 and 21? It's 3. And there is no variable with both terms, so I can't factor out a variable. So if you get stuck when you do this, you know you need to factor out a 3. Think about what 3 times what is going to give me 3x squared. Because you're kind of working backwards when you divide. That's going to be x squared. 3 times x squared is 3x squared. And then lastly over here, 3 times what is going to give me negative 21. Well, 3 times a negative number, or a negative divided by a positive is negative. 21 divided by 3 is 7. And double check your work. The same with number 2. If I look numerically, the greatest common factor is 1, but division by 1 doesn't really change anything. So I'm going to factor out an x. If I factor out an x, x times what is x squared? X times x. X times what is minus 3x? That would be negative 3. Again, you can quickly double check your work by multiplying. When you get down to number 3, what looks different is you have a negative in both terms. If I have a negative in both terms, the negative is what's in common with both, so I have to take out the negative. 5 is the greatest common factor of both of them, and again, no variable. So if I take out the negative 5 times what gives me negative 5x squared? That would be x squared. Negative 5 times what gives me negative 20? Well, that would be a plus 4, because 20 divided by 5 is 4. So again, you're taking out the negative, which is in common with both. Now number 4, we see a situation where we have both a number and a letter. The greatest common number is 2. The greatest common letter, x, appears at most once in both terms. Again, you're taking out the x, so 2x times what gives me 2x squared? That would be x. 2x times what gives me 2x? You should have said 1, because 2x times 1 gives you 2x. Right? Now, what are we doing down here, and why did we go through this? Well, if you remember from the other day where we had 2x plus 5x plus 10, right? What we're doing here is we're re-practicing factoring out a common term, because what happens when we start seeing models like this that have an a value greater than 1? Well, what we're going to do is we're going to factor by grouping, and when we factor by grouping, we group the first two, and we go ahead and we divide out the greatest common factor, and here it's x, so x times x plus 2. We factor out a 5 out of the second grouping, which gives me x plus 2. And what you should notice is that these two parentheses are the same. Yes, they are. That's how I know I did the process correctly. Now it'll be a little bit more complicated because a will be a number greater than 1. Right now a is 1. But it really won't make it that much more difficult. It'll be something kind of like this, where a is greater than 1. What I end up with is I end up with x plus 2 as one factor. I end up with x plus 5 as the other factor. That's what I end up with. And that's what we're getting to down here. They want us to rewrite this. Notice the 8's are the same. So x minus 8 is 1, and 2x plus 5 is the other. And then over here, we get 3x plus 11 is one factor, and x minus 5 is the other. So when we get to factor by grouping, this ought to be an easy process. You've already seen this step. All right? So just be cautious of that.